Hello and welcome to this lecture on integral calculus. In this video, we are going to see about evaluation of double integral in polar coordinates. Previously, we have seen a video and we have solved a couple of problems on Cartesian coordinate. So, this video will talk about a polar coordinate. First, in polar coordinate, the variables are considered as r and theta. So of course it is useful for a circular and sector shaped regions. If you go for Cartesian coordinate, the variables will be of x and y, and there will be a region called a rectangular region. And here we used to say the Jacobian for transformation as dx dy. Of course, it is a conversion. We may see later video. We will convert the Cartesian coordinates to polar form. So there we will see how it makes. Let's start the problem. So of course, as same as the previous thing in for Cartesian coordinate, we will discuss of two type. One is of constant limits. Constant limits means the limit will have only the constant values. So here the same thing. Of course, it is similar to that. Here the variables are in theta. So what we will do? Simply, I will evaluate the inner integral first. So if I take this 0 to 3 and r with respect to r means r square by 2, then 0 to 2 d theta. If I substitute the limits, then I will get 4 by 2 d theta. Of course, 0 it represents 0. So anyway, 2 will be a constant, 0 to 3 d theta. Over the integral and differentiation, it gets cancelled. So I will get theta as 0 to 3. The answer will be 6. So I'm proceeding with that. Finally, we will get the answer as 6. Now the next problem, we may refer that our limits are having the limit from 0 to 1, then theta varies from 0 to pi by 2. Of course, it is a constant. So the same process, we will make a conversion for the internal integral, and we may evaluate this with respect to r. We have to integrate this function. So with respect to r, the theta term becomes a constant. So we may keep this cos theta before the integral r theta and d theta. So then pi by 2 cos theta, and if I integrate this r square by 2, it becomes 0 to 1, then d theta, then 0 to pi by 2, 1 by 2 will be a constant. So here cos theta is there, so 1 of course d theta. So 1 by 2 integral 0 to pi by 2 cos theta d theta. So now we have to evaluate this outer integral. So let's see, it becomes 1 by 2 cos theta d theta. Integration of cos theta, it will be sine the same. Cos theta becomes sine theta, and we may make a substitution. And already we know that sine 0 will be 0. Sine 0 will be 0. Then sine 90 degree will be 1. And we make one general result. Always sine n pi will be 0, where n belongs to 1, 2, 3, goes on. The natural numbers. So with this sine 90, it becomes 1, and sine 0 degree, it becomes 0. So finally I'm getting the value 1 by 2. So on the next problem, here it is of type 2. So it is of variable limits. Here the variables are r and theta. The same process, r should not have the limit as r. So here clearly the r limit is on the form of theta, so don't worry about this. And here theta varies from 0 to pi. Of course it is a constant, we won't bother about that. So r should vary from 0 to theta, sine theta, so it depends on theta. So okay, so now the given problem is in the correct form. Now we can go for the evaluation process. The same, we will evaluate this. We know that integration of r dr will be r square by 2, and the upper limit the lower limit. Then if I substitute over the, I will get sine theta whole square, 1 by 2 will be a constant, and d theta, so it becomes 1 by 2 0 to pi sine square theta d theta. Of course, here the integration with the sine square theta little bit hard. So we may make another substitution. We know that sine square theta will be 1 minus cos 2 theta by 2. Therefore, by this formula, we may make a substitution as 1 by 2. Already 1 by 2 is there, we can make 1 by 2 into 1 by 2. So here it will be of 0 to pi and 1 minus cos 2 theta into d theta. So on the next step we get this 1 minus cos 2 theta by 2, 1 by 4. So 1 by 2 into 1 by 2, it becomes 4. So now the term is 1 and cos 2 theta. So separately we may take 1 by 4 is there, and 0 to pi we may split the integral 1 into d theta and 0 to pi cos 2 theta d theta. So here 1 by 4 integration differentiation, it will get cancelled and I will get pi value, pi minus, if I integrate cos, I will get sine. So cos 2 theta means sine 2 theta by 2. Then I have to substitute the limits 0 to pi as same. Then we know that sine n pi, sine n pi is always 0 where n belongs to a natural number simply. Then sine 0 is always 0. So while making this, I am getting the value as sine 2 pi. So if I substitute the limits over here, sine 2 pi divided by 2 minus sine 0 by 2. Anyway, I will get 0 minus 0 as simply 0. So only I am getting at 0. Finally, I am getting the answer as pi by 4. The next problem. Here r varies with respect to theta. So the limits are from 0 to 2 cos theta. Anyway, r depends on the variable theta, so it comes under variable limits. So how do we evaluate this? Similarly, internal integral, and here if I integrate r square, it become r cube by 3, and we have to substitute the limits. So how it will be? Pi by 2 and 2 cos theta whole cube by 3. 0 becomes 0, so d theta. So 2 cube it will be 8. I may keep 8 by 3 as constant, then 0 to pi by 2. Then remaining it will be of cos cube theta d theta. So same as the similar previous problem, here integrating cos cube theta, it will be harder. So we may use a formula. So already we studied about cos cube theta. It will be of 3 cos theta plus cos 3 theta divided by 4. So we may use this formula. for simplification purpose. So just see, we get 8 by 3 cos cube theta d theta. We may use this formula directly here, and we may cancel 8 and 4. It gets 2 by 3, and we have a term 3 cos theta plus cos 3 theta. So here we may solve this problem 2 by 3 and 0 to pi by 2. We may split the integral. 3 will be a constant, cos theta d theta plus 0 to pi by 2. Here it becomes cos 3 theta d theta. So we already know that integration of cos, it will be of sine, and integration of cos 3 theta, it will be of sine 3 theta by 3. So here it becomes 2 by 3, then 3, it will be of sine theta pi by 2 to 0. We know that sine 90 it will be 1 and sine 0 will be 0, then plus sine 3 theta by 3, 0 pi by 2. So upon this step, while substituting it, sine 90 it becomes 1, sine 0 it will be 0. If you go for sine 3 theta, sine 3 pi by 2, sine 3 pi by 2, it will be of minus 1, and sine 0 it becomes 0. So it will be of 3 into 1 and minus 1 by 3. So finally we get 16 by 9.